everyone. We are interested in solving a system of linear differential equations, but we're going to do so using matrices and eventually eigenvalues and eigenvectors. So considering this system of equations here, we'd first like to write this as a matrix product. So we will write the first part as a column matrix. Then the coefficient matrix of all the y's right here. So 1, negative 2, 0, negative 1, 3, 1, 2, negative 1, excuse me, 2, negative 2, negative 1. Then times the column matrix of the y's. So if you remember your matrix multiplication, it would be this, 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 equaling this that reproduces the first one. We call this column matrix the vector y prime because we know a column matrix and a vector are isomorphic. We'll call the matrix of coefficients capital A. We'll call that the y vector. So we've restated this system of equations in the form of this matrix product. Now a solution to this system that we've looked at would involve these following three vectors here, x1, x2, and x3, and then this linear combination. Now finding the e's we'll look at next time, but for right now we're stating that this is a solution to the system of linear differential equations where the c's are arbitrary constants. But I want to be able to check this answer through differentiation, which I really can't do in this form. So remembering this is the vector y1, y2, y3, we can basically break this into the pieces and say what are the actual three solutions that we need to check. So C1 times the first element here times the e will just be C1 e to the t. And then C2 times the first element and so on. And now I go to the next row. So I have 0. And then here, C2e to the negative t minus C3e to the 3t. And then finally, the last row, that would be the y3. And that would be, in this case, C1e to the t minus 3C2e to the negative t plus C3e to the 3t. So this would be a formal way of stating the solution. And now if I want to check, I would take the derivatives of each of these and then insert them back into the original equation, and that would be my ultimate check.